so 4.4 continued. We were talking about symmetry. So if you have one, let's say like this, 2x plus y squared equals 4, and your choices are, does it have x-axis symmetry, y-axis symmetry, origin symmetry, or no symmetry at all? How do I know?
Because, well, if it goes through the origin, it has origin. Right?
Not necessarily if it goes through the origin, if you can fold it. So x-axis symmetry means you can fold it over this line and it will land on itself. Y-axis symmetry means you can fold it over this line and it will land on itself. And origin symmetry means it can fold over this line or this line and land on itself. Okay, so this is, well, how do you know that? How do you know it's x-axis symmetry? You're right. Typically, whenever there's a y squared in the problem, there's a good chance it is x-axis symmetry. So we'll solve it for y to see. So if I solve this thing for y, I'll have a negative 2x plus 4, right? And then if I square root that, now remember, anytime you enter a square root into a problem, you've got to put a plus or minus in front of it. So negative 2x plus 4. Okay? All right, so what do I have here? What type of function do I have?
That is a...
It's a square root function, right? And, you know, if I were to factor out a negative 2, it's got a y-axis reflection and a horizontal compression and all that good stuff, but that doesn't really even matter because all I need to know is that it's a square root function and I've got the positive and the negative. So no matter how I shift that left or right or flip it over, it's still going to be symmetrical to the x-axis. It's not moving up or down at all. There's no number outside the square root, right? So I know it's going to stay symmetrical to the x-axis. So this one has x-axis symmetry. Does that make sense? All right, what if I have one like this? I have negative 3 over x, and it's equal to y plus 1. So as always, the first thing you're going to want to do is you're going to solve it for, not for x, solve it for y. So if I solve this thing for y, what's it going to look like?
y equals negative 3 over x minus 1.
Okay, negative 3 over x minus 1. So what type of function is that?
That is a reciprocal function.
That is a reciprocal function that's been flipped upside down, vertically stretched, and also shifted down 1, right? So if I take a reciprocal, what kind of symmetry does a reciprocal typically have, the parent function?
Origin.
Right, it typically has origin symmetry. It folds over this line that goes through the origin, right? If I shift that thing down 1, is it still going to have that symmetry? No. If I shift this thing down 1, this line would have to, the symmetry line would have to shift down 1 too, and it would no longer have origin symmetry. So once I shift it down, it would look like this, and it no longer has origin symmetry. So it has none. It has no symmetry at all. Okay, or it doesn't have any of the ones listed. I guess it would be symmetrical to this line down here, but it's not going through the origin anymore. Your origin's up here. So it doesn't have origin symmetry, x-axis, or y-axis symmetry. Okay, does that make sense? All right, what if I have this? Y is equal to negative absolute value of 4x. We may have done one like this last time, I don't remember. But we have an absolute value function. It's been flipped upside down and horizontally compressed.
Oh, well, then it's y-axis reflection.
It's got y-axis symmetry. It's not going to shift left or right or up or down, so it should keep its y-axis symmetry. Okay, so I've got a something like this. Still symmetrical to the y-axis. Y-axis symmetry. All right. Next type of problem, you're going to have to tell if a function is increasing decreasing, constant, increasing and decreasing. There's a lot of choices on this one. And then you could have increasing over 2 intervals. Or decreasing over 2 intervals. So those are all the choices on these problems. Now, Fort Scott has got this set up so that we will never encounter these two right here. We'll only encounter problems that have one of these 4. So even though you have these as choices, you're never going to have to worry about using them. You're not going to get any problems that require that. Okay? So it's just going to be these top 4 you have to worry about. So if I give you the function y equals, let's say x plus 3 quantity squared plus 2. And I want to know if that function is always increasing, if it always stays constant across from negative infinity to positive infinity. Does it increase and decrease? So in order to know that, we're probably going to need a picture, a graph. So tell me what that thing looks like if I graph it. Okay. Happy face parabola, where's its vertex at?
-3, 2.
-3, 2. Happy face parabola at -3, 2. So my parabola looks something like this, right? Didn't draw it to scale. That's okay. All I need to know is where my vertex is, and then it's a happy face. So anytime you're doing one of these problems, you ask yourself this question. If I were to drive a car on my graph from the left to the right, would I be going uphill, downhill, staying constant, or doing both?
You'd be doing both.
Okay, so if you start your car off driving from left to right, you hit this graph, from here to here, you're going downhill, right? Decreasing. And then you hit that hill, and now you're going uphill. So this graph is decreasing. It's decreasing from clear over here to here. Because remember, this goes forever up and to the left, right? Forever up and to the left. So you're always from negative infinity to this line right here, you're going to be going downhill. Where's that line at?
-3.
It's at -3 in the x-axis. So from negative infinity all the way to -3, you are going downhill. You are decreasing. Does that make sense?
Yeah. Do we have to write it like that? Like will they ask us?
They'll ask you to pick one of these 4, and if you pick this one, 2 boxes will pop up for you to type this in and our next thing. Yes, Corbin?
Wouldn't it be positive infinity to -3?
No, the negative infinity is over here. You always work from left to right across the graph. So from negative infinity all the way to this line, you're going downhill, and then from here to positive infinity, you're going uphill. Okay, so you are going from -3 to infinity is increasing or uphill. So you'll select this one, increasing and decreasing. And when you select that, 2 boxes are going to pop up. One will have the word increasing by it, one will have the word decreasing by it. So then in the decreasing box, you'll put, okay, it's going downhill from negative infinity to -3. It's going uphill from -3 to infinity. Does that make sense? Okay, where is it going increasing and where is it decreasing? All right, next example of that. Let's say I've got y equals -5x plus 2. Okay, well that's a downhill line, right? That crosses at +2. So I got a line that looks something like that. Would I choose increasing, decreasing, both, or constant? Why decreasing? It's going downhill the whole time. You drive your car on that thing from the left to the right, you're going downhill from negative infinity to positive infinity. Okay, so this is decreasing on script R or negative infinity to positive infinity. So decreasing from negative infinity to positive infinity. Everybody okay with that? right? Let's do another one. Let's say we got y equals 5. If I've got y equals 5, that means what?
It's just a line.
It's just a horizontal line. So from negative infinity to positive infinity, I'm not increasing or decreasing. I'm just staying constant, right? So this one's you're going to choose constant. Where is it constant on the negative 5?
5.
Yeah, but from where on the x-axis? Everywhere. From negative infinity to positive infinity, you're going to stay on the 5, right? So you're always giving me an x-axis reference when you fill in these blanks, okay? Where is it constant? It's constant from negative infinity all the way to positive infinity, okay? Okay, so what if I have this? Let's see, I've got f of x is equal to negative absolute value of x plus 3. So I have what?
You have absolute value, that's flipped.
Upside down absolute value, moved up 3. So it looks something like this. So if you were to drive your car on this thing, from the left to the right, would you be going uphill, downhill, both, or constant?
Both.
Okay. Yeah, that'd be great.
Okay.
So uphill, it's going uphill on this side, right? And downhill. If I can get my ink color changed. Downhill over here. Okay, so it's increasing here and decreasing here. So I would choose both, and when you choose both, something's going to pop up like this. Okay, tell me where it's increasing and where it's decreasing. Where is it increasing? Where is it decreasing? Well, it's increasing from negative infinity to?
3.
Nope, not 3.
Oh, heck.
Reference to the x-axis. So right here is where it changes, right? So from negative infinity is over here, all the way to 0 is where you'll be going uphill. From negative infinity to 0. And then 0 to positive infinity. Everybody okay with that? Okay. The last type of problem you're going to have are ones that you pretty much always have been doing since Algebra 1, but identifying how to stretch all the different things you could have. So let's say I have v of x is equal to, let's say, negative 2 x minus 1 quantity cubed plus 5. So the first thing I want you to tell is just name the function for me. What's the name of this function?
A cubic.
It is a cubic. Okay? The first question you'll get asked is, does it have a vertical translation? So you would put yes, it has a vertical translation, and then what? How does it vertically translate? Up 5. How does it have a horizontal translation? Yes, it does. And how does it move?
To the right.
To the right, 1. Okay? Does it have a vertical compression or a vertical stretch? Okay, that's a vertical stretch of what?
2.
Vertical stretch of 2. And then we have a x-axis reflection. So what if it asks you about a y-axis reflection? Then you would say no. And they're not going to give you any that do have a y-axis reflection. They all they either have an x-axis reflection or no reflection at all. Okay? So they're basically, what will happen is on your graph, you'll just pick yes or no which ones they have and tell it how to move it, and you'll get to see the graph change. Okay? They'll have the graph drawn there for you, and you'll say, hey, take it up 5, so it'll move the picture up 5. And then you'll say, hey, move it right 1, so it'll move it right 1. and so on. Okay, let's do a reciprocal because sometimes they're hard to see, or volcano. Let's say I have f of x is equal to negative 2 over x minus 3 quantity squared plus 5. Okay, so what is the name of my function?
It is a volcano.
So it's a volcano. And do I have a vertical translation?
You do.
I do. So you would say, yes, I've got one. It's going up 5. It'll have you select up or down, and then you'll type in the number 5. Okay, how about a horizontal translation?
You do.
Yes, and it moves how?
To the right.
Right 3. Do I have an x-axis reflection?
You do.
So you'll just say yes. I think it asks you for y also. Does it have a y-axis reflection?
You don't.
No. Do I have a vertical compression or a vertical stretch?
Stretch.
I have a vertical stretch of 2, and that covers it all, right? So once again, you'll just get to watch the graph move as you tell it those things.
So just ask if it has these.
Yes, it'll have, and they'll all be listed on the same page. You'll just click yes or no.
what
And if you
do
click yes, then a box will pop up to saying is it up or down.
Okay.
Okay? How far up or down? All right, everybody okay with that?
Yep.
All right, that is everything for 4.4.